I'm a professor in crop science at University of Queensland, based at Hermitage, and my main work is looking at drought adaptation in cereals. So a lot of work in sorghum, but also in wheat and barley and rice. So looking at mechanisms that give plants an advantage under dry conditions. Yeah, I started off as a crop physiologist, and that's the area that I'm still working in primarily, but it interfaces a lot with plant genetics and breeding and molecular biology and simulation modelling and those different areas. So I started there, but it probably expanded a lot into quite a few different areas. And you work in teams, and so you do good work because you work with good people, and you have to understand enough about the different disciplines to be able to be part of that team. I've always been interested in global food security, and I've always been interested in the global aspects of that. So a lot of the work I do relates to helping Australian farmers, but more broadly a lot of the work that I do relates to smallholder farmers in different parts of the world as well. So right from the start I had that dual interest in helping Australia, but then having a bigger vision for what I could do in the world. So I began as a young scientist in my mid-20s, firstly going to India when I'd finished a master's degree and just looking at the impact of the Green Revolution genes in India, and then deciding if that's what I wanted to do with my career. And I could see that it had a big impact, so I decided that that's what I wanted to do. Yeah, there's a few projects. One big one we've been looking at is around drought adaptation and a mechanism called Stay Green. So in sorghum, and it's a significant crop in Australia, but it's a big crop globally as well in places like India and in sub-Saharan Africa. And sorghum plants that keep their leaves green under drought are called Stay Green, and it results in a higher grain yield and better lodging resistance. So we've been looking at that trait in India and in sub-Saharan Africa, and places like India. So we've been working there for a 10-year period on an ACR project, and that was looking at understanding how Stay Green introgressions worked in some of their elite material, and then testing that for the drought adaptation, and then at the moment it's being scaled out through 4 of the states in India. So that was a wonderful project, looking at climate change in the sense of realising that the extremes are happening, the world's getting hotter, drier, so what type of traits does the plant need, and in India what type of plant do you need to be developing for those future changes in the climate. We've finished one recently in Vietnam as well, that was funded by the Norwegian government, and it's looking at rice-based cropping systems. And one of the things was to look at different water-saving technologies, which followed on from work that I'd done in my PhD quite a few years ago. So I had an ongoing interest in that, and also different strategies for applying nitrogen. And with the nitrogen, for example, we found out that if you applied, rather than putting on urea as a fertiliser, if you put on another form called a biochar, which is you can get rice straw and you can heat it in the absence of oxygen and create a biochar, and when you apply that as a fertiliser source, there was much less release of methane and nitrous oxide from the system. And so we measured the amount of those greenhouse gases that were released, and by using different fertiliser regimes you can reduce those emissions significantly. So that was an exciting endpoint from that study. Yeah, we've got, I mentioned before that drought adaptation trait, Stay Green, and we are now looking at a family of genes that we believe largely drives that trait. It's a family of genes called the PIN genes, and we've been doing some work on an ARC discovery project which has been looking at gene editing in sorghum and in barley, and looking at pin genes and vernalization genes, and so you can look at overexpression lines and you can look at knockouts, and we can see how these genes directly impact the canopy, which is water demand, the roots, which is water supply, and so you can really begin to look at how these genes impact traits that really drive water demand and supply. And so it's a whole new way of being able to use these new gene editing tools to develop plants that will be more drought adapted. So I think that's very exciting. So it might be a combination of using this new material with better management systems, water saving technologies, for example, at an agronomic level, and the interaction of those and new genetics, and I think that's a very exciting space. I think for farmers that if they can see an advantage in terms of their food security or their profitability, that they will grab onto a new idea very quickly. So farmers both in Australia and in the developing world have been shown to be early adapters of ideas and concepts that will rapidly change their food production technologies. So if it's not going to make a difference, they won't go with it. But if it's going to make a difference and they can see that, then they will pick that up pretty quickly and run with it. Yes, it is, because it changes their risk. So smallholder farmers have to understand risk very clearly, and they want stability, so they want to be able to produce food every year. And if there are climate extremes, then they're much more vulnerable, and they don't have the safety nets that other people might have in more developed countries. So they need to understand risk, and climate change brings a greater risk. So for them it's a big issue. So we're trying to develop crops and systems that are more sustainable and more stable, that would enable them to be able to produce food into the future. It's one of the big issues that's confronting humanity. So we've got a global population that's still increasing but might plateau somewhere around the 10 billion mark. So there's a challenge in being able to feed those people. We've got a changing climate that's happening, so we need to have crops that are adapted to a hotter and a drier world. So there's a very big place for agricultural research to be able to address that major issue. And then it's complex, so it's understanding all the different components and how you bring them together. That's where you need skills like simulation modelling to be able to look at the environment and management and genetics, and to be able to understand those complexities. Also being able to scale from a genetic level to a system level. So a lot of molecular biologists will work at the gene level, but then what does that mean in terms of a crop level or a system level? So you have to have the capacity to scale from that gene level to the crop level, and then from that level on the phenotype back to the gene. So I think those are some of the big challenges. It's complex, so we need people that can work across that space. It is one of the big issues for humanity at the moment. So it's an incredibly exciting area to be involved in, because it's one of the big challenges that humanity is facing. So if you want to do something that you're passionate about, if you want to do something that is worthwhile, if you want to do something that will make a difference in the world, then I think it's a great area to get into. For young people, I would recommend that they be proactive. So sometimes opportunities, they're not necessarily going to come your way, so you have to do things and you make it happen. When I was in my 20s, I wanted to work overseas. I started doing it with my own funds in my holiday time, and that gave me a chance to get into the developing world. And once I had that experience, and lots of other things happened. But my point is that you've got to be proactive. And if you're really keen about it, then go for it and make it happen.